Hello everyone, I'm Tarun. I'm from Data Science. My roll number 22951 A67F5. Uh, Today I'm going to explain about the video based motion captures in environments with non-stationary backgrounds in the concept of computer vision. Video based motion capture in environments with non-stationary background. Introduction to video based motion capture. Video based motion capture, that is mocap in the short form, involves recording human movements using video chat. It offers a flexible and cost effective alternative to traditional mocap systems. Challenges arise when backgrounds are non stationary, complicating accurate motion extraction. There is a little bit concept about the chapter 13, that is video based on motion capture for measuring human movement. It is a general abstract from the research papers. Just go through with that. Importance of motion capture in various fields. Motion capture or a mocap is essential in animation, gaming, and virtual reality applications. It supports biomechanics, research, and medical diagnostics. Accurate motion capture enhances realism and interactivity in digital environments. Challenges of non-stationary backgrounds. Dynamic backgrounds causes difficulties in background subtraction. Variations in lighting and moving objects introduce noise. Traditional static background assumptions fail in these environments. There is data from the research papers about the reinforcement learning in non-stationary environments. Let's go through with that abstract and the introduction about the reinforcement learning in the given non-stationary backgrounds for clear understanding and good idea. Traditional motion capture techniques. In the motion capture techniques, we have the traditional and present available techniques. Let us discuss about the traditional motion capture techniques. Those are marker based systems, rely on physical markers attached to subjects. And the next one is markerless methods, attempt to detect human pose without physical markers. Both approaches struggle with non-stationary backgrounds due to occlusion and noise. Background modeling approaches. Background subtraction is a foundational step in motion detection. Static background models are ineffective in dynamic environments. Adaptive models update over time to accommodate background changes. Like in the regional level, motion based background modeling and subtraction using MRFs. It is information from the IEEE paper published in 2007 from the Shi Xing Huang, Li Chen Fu, Pei Yang Xiao. Robust background subtraction methods. Mixture of Gaussians, that is MOG, in the short form MOG, that is mixture of Gaussians, is commonly used for adaptive background modeling. No parametric methods like kernel density estimation can handle complex backgrounds. Deep learning based segmentation models show promise in challenging scenarios. And there is a research paper information about the implementation of background subtraction for counting vehicle using mixture of Gaussians with ROI optimization. This is for the references, just go through for that good information. Deep learning for motion segmentation. CNNs that is convolutional neural networks can learn to distinguish foreground from background. Training data must include varied non-stationary backgrounds for robustness. These models improve segmentation accuracy in complex environments. A comprehensive guide to understanding convolutional neural networks. Human pose estimation in video. How the human pose is estimated in the video. Let us learn about that. Pose estimation identifies key human joints and limbs from video frames. Techniques include top down and bottom up approaches. Accurate pose estimation is crucial for reliable motion capture. Handling non stationary backgrounds in pose estimation. Incorporating temporal information helps differentiate motion from background changes. Multi-view systems can provide additional spatial context. Data augmentation improves model robustness to background variations. Multi-object tracking and occlusion handling. Tracking algorithms maintain consistent identities over frames. Occlusion handling is essential when the subject is partially hidden. Combining appearance and motion cues enhances tracking performance. There are images about the original data driven learning and the hierarchical parametric from for the data learning. Just go through with the diagrams for the occlusion handling also. Use of depth sensors and multimodal data. Depth sensors like LiDAR and structured light improve segmentation accuracy. Combining RGB and depth data assists in the separating foreground from non-stationary backgrounds. Multimodal approaches increase robustness in challenging environments. Real-time processing considerations. Efficient algorithms are necessary for real-time motion capture applications. Hardware acceleration such as GPUs speeds up processing. Balancing accuracy and computational load remains an ongoing challenge. Evaluation metrics for motion capture accuracy. Precision recall and F1 score measure segmentation quality. 3D joint position error assesses pose estimation accuracy. Robust evaluation benchmarks facilitates method comparison. It is in the actual positive, actual negative, predicted positive and predicted negative. Go through with the given table and the precision recall formulas for good understanding. Case studies and applications. Motion capture in outdoor or cluttered indoor environments demonstrates real world utility. Applications include sports, analytics, and surveillance. Adaptive background modeling significantly improves performance in these scenarios. Future directions in video based mocap, that is motion capture. Integration of deep learning with traditional methods promises enhanced robustness. Development of unsupervised and semi-supervised models reduces training data needs. Advances in sensor technology will facilitate better environment understanding. Challenges and limitations. Handling several lightning variations remains difficult. Computational complexity can limit deployment and resource constrained settings. Occlusion and fast and movements still pose significantly obstacles. Summary of Key takeaways. Non-stationary backgrounds require adaptive and robust segmentation methods. Combining multiple data modalities improves motion capture accuracy. Ongoing research aims to address current limitations for broader applications. Just go through with the diagrams for the good key takeaways from the concept. Practical recommendations for implementation. Use adaptive background models tailored to specific environments. Incorporate deep learning based segmentation for improved accuracy. Regularly evaluate system performance with relevant benchmarks. Conclusion. Video based motion capture and dynamic environments is an active research area. Advanced algorithms and sensors are expanding capabilities. Continued innovation will enable more reliable and versatile motion analysis systems. Thank you. I hope you learn something from this presentation. Thank you everyone. See you in the next video.